When the light coming from the source is passed through the prism, the impression recorded on the photographic plate is called as spectrum. For example, just like fingerprints of any two persons cannot match together, different atoms are going to have different spectrums. So spectrum is one of the way of identifying an element. We have two types of spectrums: emission spectrum and absorption spectrum. The spectrum produced due to emitted radiation is called as an emission spectrum. Means when electrons fall from higher orbits to lower orbits, energy is emitted, then it produces emission spectrum. Emission spectrum contains bright lines on dark background, whereas other type of spectrum is absorption spectrum. The spectrum produced due to absorbed radiation is called as absorption spectrum. In absorption spectrum, we will find dark lines on bright background. Thus we can say absorption spectrum is almost a photo-negative of an emission spectrum if we consider the same sample of the gas. And one more thing, spectrum formed by atoms, that is called as line spectrum. For example, hydrogen atom produces a spectrum called line spectrum, whereas spectrum formed by molecules, that will be called as band spectrum. So atoms form line spectrum, molecules form band spectrum. Line spectrum contain sharp distant lines, whereas band spectrum contain closely spaced lines called as bands separated by distance. Thus one of the very important topic from this concept is this model could explain line spectrum of hydrogen and hydrogen-like species. Helium plus, Li plus 2, beryllium plus 3, all these three contain one electron like hydrogen, hence they are called hydrogen-like species. So Bohr's theory was successful in explaining atomic spectrum of hydrogen and hydrogen-like species. The second advantage of this theory is this theory proposes derivations for radius of an orbit and energy of an electron. Based on the principal quantum number, as the value of n increases, radius of the orbit, means size of the orbit increases. And one more thing, as the value of n increases, energy of electron also increases. However, this theory has some drawbacks. The first drawback is it could not explain fine spectrum of hydrogen. When hydrogen spectrum was observed under a powerful spectroscope, some lines are found to be group of 2 or 3 lines, that is called fine spectrum. That is not explained by this theory. It could not explain Zeeman effect and Stark effect. Means splitting of spectral lines in applied magnetic field is Zeeman effect. Splitting of spectral lines in applied electric field is Stark effect. That could not be explained by this theory. Third drawback, this theory contradicts Heisenberg uncertainty principle. Heisenberg's principle states that simultaneous and accurate determination of position and momentum of electron is impossible. That principle was opposed by this Bohr's theory. And the fourth important point in the demerits, this theory fails to explain atomic spectrum of atoms which contain more than one electron. So these are the drawbacks of Bohr's theory. Even though these drawbacks are most number of drawbacks are there here, but this is one of the important success theory in understanding the structure of an atom. In the classes 8th and 7th books in our material, so many questions are related to this topic. Bohr's theory is very, very important. And we need to mainly concentrate in the problematic part related to calculation of angular momentum and finding energy of an electron. Remember a point, energy of electron is least in first orbit. As the orbit number increases, means circular path increases, energy of electron also increases. As the value of n increases, radius of orbit also increases. These are some of the important points in Bohr's atomic theory. And we had one more important discussion here. When we consider spectra, for example, light coming from the source, let us imagine this is a light source. It may be an electrical bulb or a burning candle. But the light is passed through a slit and allowed to fall on a prism made up of glass. Prism causes dispersion of light like this, and when the light is allowed to fall on photographic plate, spectrum is recorded. Thus we can say spectrum means the impression developed on photographic plate when the light coming from the source is analyzed through the prism. So many elements in the periodic table were discovered by identifying their line spectrum. Helium in sun atmosphere was identified by its line spectrum. Similarly, the elements like scandium, gallium, indium, thallium, rubidium, all these elements were identified by considering their line spectrums. So this is one of the important methods for identifying elements by considering their spectrums. Thus, already I discussed there are two types of spectrum, emission and absorption spectrum. This is about Bohr's theory. The next important point here is to overcome one of the drawback of Bohr's theory. One more model was proposed, that is called Sommerfeld's theory. According to Sommerfeld, electron revolve around the nucleus in circular path as well as elliptical path. According to this theory, electron is revolving around the nucleus in circular path like this and elliptical path like this. And this model first time introduces a new quantum number called as azimuthal quantum number. It is denoted by K. Of course, later onwards it was modified as L, small l. But at earlier days of this theory, azimuthal quantum number was denoted by K. For a circular orbit, the important relation is n is equal to k, means principal quantum number is equal to azimuthal quantum number. Whereas in elliptical orbit, the important relation is n is not equals to k, means principal quantum number is not equals to azimuthal quantum number. And these two are related as n by k is equal to length of major axis divided by length of minor axis. The two quantum numbers n and k. In an orbit we have two types of axis. One is major axis, other one is minor axis. Here also in elliptical path there are two axes. Thus n by k is equal to length of major axis by length of minor axis. Then for a circular orbit the important condition is n is equal to k. For an elliptical orbit the important condition is n is not equals to k. And we learned according to Bohr's theory in a circular orbit, angular momentum of revolving electron is Abhyas is equal to nh by 2 pi, where n is principal quantum number. Whereas in elliptical orbit, mvr is equal to kh by 2 pi, where k is called as azimuthal quantum number. This azimuthal quantum number denoted as k can have values from 1, 2, 3 and so on. Later onwards, it was changed as L, which can have values from 0, 1, 2, 3 only. So K and L are both represents azimuthal quantum number, but nowadays azimuthal quantum number has to be taken as L. The maximum value of L is n minus 1. K consideration is according to the old considerations. The significance of this azimuthal quantum number is it explains fine spectrum of hydrogen, which is one of the drawbacks in Bohr's theory. Because in an orbit, according to this theory, subshells are present. S, P, D and F. These are called as subshells, which are present in the orbit or shell. Bohr's theory could not explain the presence of these subshells because it proposes only main orbits, that is n is 1, 2, 3, 4. In those main orbits, subshells like SPDF were proposed by Sommerfeld. Thus, azimuthal quantum number indicates subshells that are present in the main shell. And azimuthal quantum number explains the shapes of the orbital. S orbital is spherical, p orbital is dumbbell, d orbital is double dumbbell, f orbital is fourfold dumbbell, or it is a complex shape. Thus, principal quantum number is proposed by Bohr. Azimuthal quantum number was proposed by Sommerfeld. And the advantages, principal quantum number introduces orbit, stationary orbit, whereas azimuthal quantum number introduces or proposes subshells which are present in the orbit or shell. These are some of the important points in Sommerfeld's atomic model. Now, the next important point here is calculation of number of electrons, protons in cases of ions. For example, when we consider elements having atomic numbers 1 to 30 must be done by the students in order to do problematic part easily in this chapter. If I am going to consider sodium, atomic number 11, so protons will be 11, electrons will be 11, and the symbol for sodium is 1123. So number of neutrons will be 23 minus 11, that will be 12. When a symbol is given like this, the question may be calculate the total number of fundamental particles. Protons is equal to atomic number, electrons also equal to atomic number, neutrons equals to A minus Z. Thus, sodium has 11 protons, 11 electrons and 12 neutrons. When sodium is converted to Na+, this is called as cation. The ion formed when a neutral atom loses an electron is called as cation. If one electron is lost, plus 1 is observed. If two electrons are lost, plus 2, thus cation consists of only positive charge. So when a neutral atom converts to cation, there will be no change in protons and neutrons, but there will be change in electrons only. So in the case of Na+, like neutral atom, protons will be 11, neutrons will be 12 like neutral atom, but electrons will be atomic number means 11 minus charge present on the ion, because here one electron is lost here. That's why Na+ is formed. So whenever number of electrons in a cation is asked, atomic number minus charge present on the ion has to be considered. As charge here is plus 1, so 11 minus 1, 10. Therefore, one important point here is neutral atom means atom without charge, and cation must differ in number of electrons. They may be having same number of protons and neutrons, but they should differ in electrons in case of a cation. Similarly, in case of anion also the same discussion. If I take chlorine, atomic number 17, so it will be having 17 protons, 17 electrons. If it is becoming as Cl minus, that is called anion. Anions are formed by gaining one or more electrons. Anions contain negative charge always. So protons will remain same and electrons will be atomic number plus charge present on the ion. Here the charge is how much? Minus 1 means 1 electron is gained. That is plus 18 it will become. So two important points here from this discussion. In cation, number of electrons is equal to Z minus charge on ion, whereas in anion, number of electrons is equal to Z plus charge on ion. Z minus charge on ion will give the number of electrons in cation. Z means what? Atomic number. Z plus charge on ion will give number of electrons in anion. Thus in a cation and anion, there will be no change in protons and neutrons, but there will be a change in electrons only. That point is very important. So in the problematic part of calculation of number of electrons, protons, this area is very, very important in this chapter. So in the problematic part of this chapter, first important area is wave characteristics, where we had problems related to wave characteristics. One is frequencies c by lambda, wave number is 1 by lambda, energy of radiation is E is equal to hg. Problems based on these three formulas are very important in this chapter. And we also had problems related to Bohr's theory, that is mvr is equal to nh by 2 pi. That is calculation of angular momentum in a circular orbit. Next, energy change when electron jumps from one orbit to other orbit. That is delta E is equal to E2 minus E1 is equal to h nu. Problems based on this mode is also very important. H nu, we can also write it as C by lambda in the place of nu, or we can also write it as Hc nu bar. Problems based on this model is also very important. And we had one more important point here. Values of Planck's constant, we have to remember, that is 6.625 into 10 power minus 27 Nm second in CGS system. And we need to also remember velocity of light, 3 into 10 power 10 centimeter per second. These two values are important in doing the problems. And other important areas, calculation of the fundamental particles. That is sum of protons, neutrons and electrons. And the concept of isotopes, isobars, isotones and isoelectronic means the spaces having same number of electrons are called isoelectronic. That concept is also very important. So with this I am completing